This is Josh White with JW Math Tutoring. In this video, I'm going to go through Bluebook, Digital SAT, Practice Test 9, the Math section, Module 2B, the harder of the two second modules. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Just before I begin going through Digital SAT Practice Test 9 from the Bluebook app, Module 2B, the harder of the 2-second modules, please keep the following things in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the time for this video to go through the 22 problems will most likely be greater than the 35 minutes that you're allotted. And that's because in some of these problems I will show, multiple methods to solve them, possibly even 3 or 4 different ways. So obviously, when you're taking an official exam, you would not need to do that. You basically only need to solve the problem once, or maybe you use a second method to check your answer if you have time. Okay, so just keep that in mind. And third, if you haven't done so already, please do check out the videos to Module 1 from this same Practice Test 9 in the Bluebook app, and also Module 2A, the easier of the 2 second modules from the same Practice Test 9. All right, so with all that being said, let's go ahead and get started. Bluebook, Practice Test 9, Module 2B. First question, what is the median of this data set shown here? So if you notice, these are all values are listed in ascending order. So we can actually, use the method where you just start at either end and cross everything out. And then in this case, we're left with one item in the middle. So that's just the answer, which is 79. If you were left with 2 items in the middle, then you take those 2 values and you average them. And that average becomes your median. Now, you could obviously, of course, also go to Desmos and you could just type in the median function and then you could type in all the values. Uh, 79, 82, 84, 85, 91. And there we go. The median is just 79. Desmos will give us the answer as well. All right, next up, number 2. Here we have some right triangles. So we know that angle M up, so I'm just going to do it like this. LMN and PQR. We know that M is 53 degrees. Okay, so M obviously can't be the right angle. What is the measure of angle Q? Well, M corresponds to Q. When you have similar triangles, the corresponding angles are congruent. So Q will also be 53 degrees. The correct answer for this one is just letter B. Next question, number 3. Here you have a table of values for a function, and all you're really doing in this problem is plugging in 3, finding out what its y value is, and then that's the answer. That's the value of a in the table. So it's really just 4 times 2 to the third plus 3. 4 times 8 plus 3. 32 plus 3 equals 35. So correct answer for this one is letter B. Of course, you could go to Desmos and you could just do the calculation in Desmos instead of doing it by hand like I did. That's perfectly fine. You're just going to get the same answer. Next up, question number 4. This is actually a repeat question from the one of the practice tests 1 through 3, the ones that were removed. So how many solutions does this equation have? So notice if you try to solve this, like if you try to subtract 66x on both sides, you get 0 equals 0. That statement is true regardless of what x value you plug in, just like the original statement as well. You plug in any number for x, and both sides are going to be the same number, meaning that the value that you plug in for x is a solution. So the correct answer to this is C, infinitely many solutions. Now, in Desmos, the way you'd want to solve this is you want to graph y equals left side, y equals right side. And hopefully when you do that, you're going to notice, hey, it's the same line on top of each other or overlapping each other. That's infinite solutions. What you do not want to do is you do not want to just type the equation as it's given, because what you will see is just a blank graph. You will see nothing. So you might think, oh, that means it's no solution or zero solutions, letter D, but that would be wrong. So that's why for these problems where it says how many solutions and it's a single linear equation, you absolutely need to graph again y equals left side, y equals right side, and then look to see if there's one intersection or if it's the same line over top of itself overlapping, which is infinite, or if it's two parallel lines, which is the no solution, or in this case, zero solution. All right, next up, number 5. Basically, we're finding the function or the equation for an exponential growth situation. So the starting population is 15,000. So that right off the bat, I can eliminate A and B because 15,000 is going to have to be out here in front of the base, which is raised to the exponent. So now it's increasing by 4% per year. So essentially that means you're taking your current population, multiplying it by 0.04, adding it to that current population, and then that's your new answer. The correct answer for this is going to be D because it's increasing. Because for exponential either growth or decay, the general form is like A times 1 plus or minus R, say to the X. A is your initial amount. We know that's 15,000. R is your percentage, increase or decrease. So in this case, it's 0.04. Because it's increase, you add it. If it was decrease, you would subtract it, 1 minus 0.04. So the correct answer for this one, as I said, is going to be letter D. Next up, we have a function, specifically a linear function, and we want to add together the value of its x-intercepts and its y-intercepts. So you could do this by hand. However, honestly, I'm just going to go to Desmos because it's going to be so much quicker. All you have to do is just graph the function. Let's get a better view here. Oh, maybe not. Zoom out a little bit. Okay, what is a plus b? So the x-intercept or a is 7. The y-intercept or b is 28. 7 plus 28 is, whoops, nope, incorrect, typo. Here's the correct graph, 4x plus 28. -7 and positive 28. I was going to say the answer did not match what I have in my notes. So -7 plus 28. The correct answer should be 21, letter A. All right, next up, number 7. Which expression is equivalent to this gigantic rational expression or fraction here? So the way to do this by hand is to notice that on the top, both terms, if you want to call them that, have an x minus 7 in common. So you can factor that out, and then you're left with 8x minus 3. On the bottom, there's a 2 in common, so you can factor that out, and you're left with just x minus 7. Now notice these completely cancel out, so you just get 8x minus 3 over 2. So the correct answer for this problem is letter B. However, you can also do this in Desmos. Just take you a little bit of time to basically type out the original expression, okay? And then you would go through the answer choices. So if I started with A, I would say, okay, do these things overlap? Clearly not. Then I would go to B, 8x minus 3 over 2, and notice I have the exact same graph right here. So this is the correct answer. You could try C, you could try D, you could see, you'll see that they're not going to overlap completely to the original expression, but this is how you can match these two expressions in Desmos. All right, next up, number 8. We have two circles. One has a radius of 3n, the other has a radius of 129n. How many times is the area for B compared to A? So most people would probably go ahead and say, okay, the area of A is going to be 3n squared times pi, 9n squared pi. And for B, it's going to be pi times 129n squared What number is that? 16,641 n pi. Sorry, n squared pi. All right. So now, how many times is b is how many times a? So like notice the pi's cancel out, the n squareds cancel out. So really we're looking at like, 9 times what number? So this is a times what number is equal to the area of b, 16,641. Or in other words, it's really the 16,641 divided by 9. So if you do that, it's going to be 1849. Okay, so the correct answer is letter D. But really, kind of the theoretical way to do this, or really like, I guess you could maybe say like the shorter way is the radius of A, or excuse me, the radius of B, which is 129, is, how many times the radius of A. So, well, 129 divided by 3, if you divide those, it comes out to 43. So the radius of B is 43 times greater, but the area is a function of the radius squared. So 43 squared is how many times the area of B will be greater than times the area of A. And again, 43 squared is just 1849. So that's just an alternate way to think about it without actually technically needing to calculate the areas. Basically, you find the ratio of the two radii, which is essentially 129 over 3 or 43 to 1, and then you square that, and that gives you the area factor. In other words, the radius is 43 times greater, the area is 1,849 times greater. All right, next up, question number 9. This one, I believe, is also a repeat question from the previous practice test. So you have a circle. You have its center here, O. We have R. We have S. And we have a triangle ORS. So we can just connect these. All right. The measure of ROS, which is this angle right here, okay, is 88 degrees. What is the measure of RSO? So what you need to know in order to solve this is that this side is a radius and this side is a radius. Therefore, they are each congruent. In a triangle, basically, if you have a pair of congruent sides, then the angles opposite those sides will also be congruent. So in other words, this angle here and this angle here will be congruent. So we have 180 degrees minus the 88 for ROS. That leaves us with 92 degrees. That 92 degrees will be split up evenly because angle R is congruent to angle S. So they're each going to be 46 degrees. So the correct answer for this one is just 46. All right, number 10, another repeat question here. You have a budget of $14,000 to purchase chairs with. You also have basically the 7% sales tax to deal with as well. So really the equation you're setting up here is you have 81 people, and then you have the price of the chair, let's say X. But then you have to account for sales tax of 7%. And then that amount has to be less than or it could be equal to $14,000. So the way you account for the sales tax is you just multiply this by 1.07. Okay? You just basically take 1 and you add the 7% or the 0.07 to it, and that's the shorthand way of doing it. Rather than technically doing like 81 times x plus 81 times x times 0.07, where this is like the share price before tax and this is the amount of the sales tax, you can just combine them together and just make it times 1.087. Or sorry, 1.07. So now if you just multiply these together and then divide, you should get x is less than or equal to 161.532248. Let's just check that in Desmos to confirm. So we got 14,000 divided by 81 times 1.07. Can't see it because I got to erase this. Yep, 161.532248. Yeah, just cut off a couple decimal places. All right. So which one's close to the maximum possible price? Okay, too high, too high. So B is acceptable because notice 161.53 is technically less than this because this has additional values after the 0.53. So the correct answer here is going to be letter B. And if you just go through and test it, 161.53, let's say that's the cost of a chair. We need to buy 81 of them, and we also have to account for sales tax. Is the amount less than or equal to $14,000? Yes, 13,999.81 cents it would probably round to. And now this what I'm doing right here, this is actually back solving. Like you could back solve this problem as well. You could basically start with answer choice A, and you could just plug everything in as I have it here. It's just to be 148.15. And then C, is that less than 14,000? Yes. Move on to B. C, is that less than 14,000? Yes. You probably then would not even need to check C because notice how close this is to 14,000. You know, it's like 19 cents less than it. So that would pretty much tell you that B is the correct answer. All right, next up we have question number 11. Here we have a right triangle. It has legs of 24 and 21. The hypotenuse is 3 root d. So what is the value of d? All right, so if you write this out by hand, it's right. It's 21 squared plus 24 squared equals 3 root d quantity squared. And then what you're going to end up with is 1017 on the left here. And on the right, 3 squared is 9. Root d times root d is just d. And then you divide this, and you get d equals 113. So in other words, the hypotenuse, when you simplify it all out, it comes to 3 root 113. Okay, so that's the correct answer. Now, you could, of course, do this in Desmos. It's actually not going to be a lot of work because we're just going to do 24 squared, 21 squared. We're going to do regression because we want to use d, and we just do this. And, oh, I need to remember, it's not giving me that, I need to square this, of course. There. Now we have d equals 113. That's the answer. Just type the Pythagorean theorem equation. It's Desmos, but I used a tilde for regression. It's 113. We can move on to the next problem. All right, next up, we have question number 12. So here we have a percentage question. So A is 230% of B. In other words, A is 2.30 times B. And A is also 60% of C. So A is 0.6 or 0.60, we're going to write it, times C. Now, if C is P% of B, which is defined by both, okay. So first we need to do is set these two equations equal to each other. And then notice the way it's worded. C is equal sign P% blah, blah, blah of B. So we need a final equation that says C equals everything else on the other side. So we have to divide by 0.6 here. So if you do that, basically 2.30, 2.3 divided by 0.6, you get 3.833B equal to C. But here's the thing, okay? Notice that when it's written like this is the decimal equivalent of P. In other words, to convert this to a percentage, you have to multiply it by 100%. And that moves the decimal over 2 places. So the correct answer for this is just going to be letter D, 383. Now, how could we do this in Desmos? Okay, so in Desmos, first thing I'm going to do is just type the A equals 230% of B statement. I'm going to define B as 100. I'll explain why I do that in a second. Then I'm just going to do A. I'm not going to do an equation. I'm going to do a regression. A is 60% of C. The reason I do a regression is because that will find the value of C in order to make this statement true. based on the value of A that it's grabbing from the first statement, which is based on the value of B of 100 in the second statement. Now, when I do that, notice I have the correct answer for C. The answer for C right now is the 383. It's the answer to the problem. Okay? And the reason is because since I defined C as, you know, T% of B, and B, well, sorry, C is P% of B, that's given. But because I defined B as 100 in the problem, basically this number right here is going to be my correct answer because this is the percent, this is basically the percentage, out of, um, not out of, but, multiplied by B or multiplied by 100. The point is, if you picked a different number for B, then you would have to do additional work to solve, that for C is P% of B. But because you do this, but because you define B to be 100, um, therefore, you know, essentially the C value that we get is just the answer. Because if you think about it, C is P times B, right? So if I set this to 100, whatever this number is, it's being multiplied by 100. So the multiplying by 100, the reason since I set B to 100, multiplying this number by 100 turns it into a percentage. In other words, it turns it from like the decimal P into the percentage P. And then that like the percentage P is just equal to C. So that's why 383 right here at bullet point B33 is the correct answer when I set B equal to 100. So that's the key to this problem. That's how you could do the entire problem in Desmos. All right, next up, question number 13. So let's talk about this one. You have a function that tell you it equals 201, f of x equals 201% of x. So which of the following could describe this function? So f of x equals 201%. Now as a decimal, that's 2.01 of multiplication x. So when you just take it and translate and write it out, you can see this is clearly a linear function. It's just y equals 2.01x with a y-intercept of 0 and a slope of 2.01. So it's just an increasing, linear function. Now, if you weren't convinced, you could also just like make a little table with x and y values. You can start like 1, 2, and 3, and you just go to Desmos and you do like 201% of 1, and it's going to give you 2.01. And then you do it for 2, and it's going to give you 4.02, and you do it for 3, and it's going to give you 6.03. And then when you look at these, you should be able to recognize that this is linear because the difference between the y values is the same. It's 2.01 when you subtract the y values, regardless of whether you're going from 1 to 2 or 2 to 3. For it to be exponential, the difference, i.e. the subtracted amount, would not be the same. For exponentials, they would all be multiplied by the same number, but that's not the case here. You don't multiply by the same number to get from 2.01 to 4.02, and then again to get from 4.02 to 6.03. So this one is going to be letter D, increasing linear. Next up, we have question 14. This one is a repeat from the previous practice tests. I forget which one's on, but it's on one of them, 1 through 3. And so for this question, I don't know of any way to do the problem entirely in Desmos. Once you find the value of k, you can then of course go do the regression in there. But the key is they tell you that since the y-intercept is k minus 5 comma b, that you have to know that therefore k minus 5 equals 0, because the y-intercept always has an x-coordinate of 0. So if we just add 5, we get k equals 5. Now you can just go do a linear regression on the points 12, 13, or excuse me, not 12, 13, 5, 13, and then 12, negative 15. And so we can then I'll just go to Desmos because it'll be quicker and easier than doing it by hand. So again, we create the table 13, 12, -15. We can click on this. Linear regression is what we want. What's the value of b? What's our y-intercept value? Well, you can see right here it automatically gives this to us as 33. So the correct answer for this problem is just 33. And we can move on to the next question. All right, here you have an basically linear interpretation question. So notice 32 on the number that's on the right equals cups. Okay, so that means 3x has to also be a number of cups. And 5y also has to be a number of cups because you have number of cups plus number of cups, and the total result has to be 32 cups. So what does the 5y represent? So, okay, I just basically eliminated a and b. It's not the number of jars. It has to be the total number of cups. And then notice y is the number of large jars. So therefore, the correct answer for this has to be letter C. It's the total number of cups that come from large jars because of the fact that it has the y as part of it. Next up, question number 16. Here you have a single linear equation, two variables, i.e. a line. And you want to know which of these could be the second equation for the system if it has no solution. So if you're going to do this by hand, what I would do is I would take the first equation, I would put it in a slope-intercept form, so you get 3x plus 45 equals 36y, and then you can divide by 36. Okay, so notice the slope of this first equation, this given equation here, is going to be 3 over 36 or just 1 over 12. So now we are looking for the line that has a slope of 1 over 12, and also more importantly, it cannot have the same y-intercept value. So if just a notice here, 45 over 36, that's going to be, I think, 5 over 4. Let's just confirm. Simplify fraction, we can just do this and then click the button. Yep, 5/4. Okay. So this 5/4. All right. So let's go through these and just check the slope. Okay, A, divide by 4. So we get y equals 1/4 x. Is that slope 1/12? Same thing? Nope. Eliminate it. B, divide by 4, divide this by 4. 1/3 divided by 4 will equal 1/12. So, sorry, y equals 1/12 x. So this one, we keep it for now. Now, C, we go through, add the 15 to the other side, x plus 15, okay, and we divide by 12, divide by 12, divide by 12. So notice here, we get a slope of 1/12, which matches the slope from the original line. However, here's the thing you have to be careful with. This y-intercept, 15 over 12, I believe will end up being identical to the y-intercept of the given line, meaning if I take 15 over 12, okay, it's the same number. Look, do this. See, it's 5/4. So therefore, C is not the correct answer because the slope and the y-intercept are the same. We need the slope to be the same, but the y-intercept to be different. And lastly, with D, if you just add 15 here, 1/3 x plus 15 equals 12y, and you divide by 12, okay, this slope is going to be 1/36. It's not going to be the same slope. It does have the same y-intercept, but it doesn't have the same slope, so that one's out. So the correct answer for this one is B. And of course, if you go to Desmos, honestly, it'll probably be quicker to just graph the original line, original equation, and then go through your answer choices and see, do they look parallel? Like these, obviously not parallel, they intersect right here. Okay, next one. These, pretty clearly do look parallel. You zoom out a little bit. But if you want to be sure, you can look at the other answer choices. Okay, notice here it's overlapping. This is infinite solutions. This is not no solution. And then lastly, For D, okay, we can see they clearly intersect right here, basically at the y-intercept value. So you could also do this one quite easily in Desmos as well. Next up, question 17. This is another repeat question. So there are multiple ways that you could solve this. I will show you. If you wanted to do it the theoretical way, the way that I would actually do it is I would subtract this whole term over to the right. So I'd get 0 equals x minus a times x minus 29 and then minus x minus 29. Then you could factor out an x minus 29 from both terms, and what you're left with is x minus a, that's this right here, and then here you just have a minus 1. This whole thing gets factored out, so there's really just a 1 left. Now you have your two factors that you can set equal to 0. X minus 29 equals 0, therefore x equals 29. X minus a minus 1 equals 0, therefore x is equal to, well, you add a and you add 1, a plus 1. So a plus 1, check. 29, check. Correct answer for this should be 2 and 3 only, which is letter C. Again, that's the theoretical way. If you didn't understand it or didn't follow it, that's totally fine. Let's go to Desmos and do it in there. So what I'm going to do is I'm going to graph y equals left side, y equals right side. And then I'm going to look for the intersection points, and I'm going to see, excuse me, which of these values I find on my graph. Now, make a slider for a, but notice a has to be greater than 30, so I'll just set it to 31. It doesn't have to be an integer, but I'll just, whatever, set it to an integer. Okay, so now let's zoom out a little bit to see what's going on here. Okay, so where are my solutions? Okay, I have 32 and 29. So right off the bat, 32 and 29. So it looks like 29 is going to be 1, since I see it at least for this example. And now what is 32 relative to A? Because if A is 31, then 32 would be just A plus 1. So it looks like it's these two, but let's just move the slider and confirm. So let's bump this up, whatever, just to 40. So if you notice, the 29 stays as a solution. Like this, right here, it keeps intersecting it, at 29 comma 0. However, the other one moves, but notice it's always 1 more than my A value. Here it's 35.7 versus 34.7. Here it's 35 versus 34. So this is how you could determine in Desmos that yes, 29 is a solution, A plus 1 is a solution, therefore it's letter C, 2 and 3 only. Next up, we have number 18. So this one, I will show you the theoretical way, and then after that, I will show you how you could use picking numbers with actual numbers to solve this as well. So basically, you are staining this fence in the yard twice, okay? And the total area of the yard is W. So therefore, you are staining 2W square feet in total. All right, so that's what I'm starting out with. I'm basically just going to do, what we're going to do is we're going to do this one as a unit conversion problem. Now, we're staining that many square feet, and then what we know is 1 gallon will cover 170 square feet. So that's our conversion factor we're going to multiply by. So notice, square feet cancel out. What do I get as my answer? Well, 2W over 170. Now, that doesn't match exactly any of the answer choices. It doesn't match A because it doesn't have a 2 on top. It obviously doesn't match B. It doesn't match C. However, it actually does match D because the 2 over 170 just gets reduced to 1 over 85 because they have a common factor of 2. So the correct answer for this problem is letter D. Now, here's how you could pick some numbers to solve this out and get your answer. So I'm going to say that the total area for this fence is 600 and, what did I choose? No, 340 square feet. So I'm setting W equal to 340. Therefore, the total 2W, the total area that I need to cover is 680 square feet. Okay? Now, I have 680 square feet that I need to cover. 1 gallon will cover 170 square feet. So if I just divide those, 680 by 170, I'm going to need 4 gallons of this stain. So now what you do is you go through all the answer choices and you plug in 340 for W and you see which one equals 4. So probably easiest just to do this in Desmos. First, I'm just going to set W equal to 340 here, and then I can just type W over 170. Is it equal to 4? No. 170W? No. 340W? No. W over 85. 4, yes, that's our correct answer. So again, I'm doing picking numbers here. I'm picking a number for W, then I'm using that to calculate how many gallons I would need based on the information in the problem. Then I go through the answer choices. I see which answer choice equals the number that I've calculated when I worked the problem out, which is 4. All right, next up, problem number 19. So you have this quadratic equation here and intersect some line at exactly 1 point. What's the value of C? All right, first thing I would just mention, because this is multiple choice, this is actually incredibly quick and easy to do in Desmos because all you have to do is just type in the answer choices or, basically make a slider. So I'm going to type y equals c, and then I'm going to let c equal, first I'm going to start off with this. All right, I don't see anything on my screen, so let's just zoom out. Okay, so there's my line, there's my quadratic. Do they intersect at exactly 1 point? Of course not, so that's not the correct answer. Do these intersect at exactly 1 point? No. Okay, not the correct answer. Let's try C. These, it looks like they intersect at 1 point. You can zoom in and notice there is one clickable point. So the correct answer for this is going to be letter C. That's how you can do it in Desmos. Honestly, I think that's the fastest method, but I will show you how you could do this by hand in case you have a free response question that is not multiple choice where you are not given answer choices to type in. So essentially what we're doing is we have y equals c and we have y equals negative x squared plus 9x minus 100. So we're going to set them equal. So I can just replace this with c. And now if I get this equal to 0, notice I'm going to just basically, you could move everything over to the other side, or you could think about it multiplying by -1. I'm just going to make it so that the a term, the coefficient in front of the x squared, is positive. So I'm going to make this x squared, then minus 9x, then plus 100, then minus c. Okay, equals 0. All right. So there's multiple ways you could do this. One method is to look at the discriminant, the b squared minus 4ac. So if you do that approach, it's going to be negative 9 squared minus 4 times a times c. So you get 81. And then here we have negative, this whole thing is just -4 times 100. So it's minus 400. -4 times -c plus 4c, again, equals 0. Because it intersects at exactly 1 point, that means we want exactly one real solution. That's why I'm setting the discriminant, the b squared minus 4ac, equal to 0. And then I'm just going to solve this for c. So 81 minus 400 is going to be negative 319 plus 4c equals 0. Now I add that to the other side, except I'm getting positive 319 over 4 instead of negative. So let's double check what is the mistake that I have made. Plus, minus, plus. Oh, I see what it is. This was minus c when I moved it over to the right, but when I move it over to the left, it needs to be plus c. So this is plus c. Therefore, this is minus 4c. Now we get negative 319 over 4, letter C. However, there's also a second way you could do this. Maybe it's quicker, maybe it isn't, but I'll just show you real quick. Okay, so that method was using the discriminant. Here is how you could use the idea or the principle of completing the square. So, let me just erase this. Okay. So essentially, an alternate way to think about this is, essentially you're going to complete the square, because when you complete the square, you get the same factor twice. The way completing the square works is you take the b value, you divide it by 2, and then you square it. So in other words, if I was going to complete the square with this quadratic, the way it would work is it would be x squared minus 9x plus, and then plus 81 over 4, and it would factor as x minus 9 halves quantity squared. All right? So the point is, to complete the square on this, which gets you exactly one real solution, which is what we want, this whole thing has to equal 81 over 4. Okay, so in other words, 100 plus c equals 81 over 4. So you just minus 100, c equals, let's see here, 81 over 4 minus 100. All right, it gives us this thing, but let's just, there it is, it's fraction negative 319 over 4. So if you're familiar with completing the square, then this method might be quicker, might be faster, but if not, just ignore it. Use a discriminant or just literally type the values into Desmos and get it that way. But this is just an alternate way you could do this one as well. All right, next up, question number 20. Here we have a quadratic function. Basically, this maximum thing here is going to be the vertex. Okay, so the vertex is going to be the point 6, 302.4. Time is your x, and the function g models depth. So that means the depth is your y. All right. We also know it reached the surface 12 minutes after it entered the water. So that means when time is 12, its depth is technically 0. So you can solve this by hand, or we can also get it in Desmos. Basically, what we're going to do is once we get the equation, really once we find out a, then we're just going to plug in 10 for x and just calculate out whatever it works out to. So what you do here is you plug in all the various points we have. So for y, we plug in 0, a, we don't know, x, we plug in 12, h is 6, because that's part of the vertex right here, squared plus k is 302.4. This becomes 6. 6 squared is 36. So you get 36a equals negative 302.4. Divide by 36. A should come out to equal, where are my notes here? Negative 8.4. Let's just go to Desmos to check it. Yep. Okay, so now, and I'm just going to do this in Desmos. So now what we can do is we have the equation. We can just go y equals negative 8.4, x minus 6 squared plus 302.4. And we can just plug in 10 for x. Again, I'm not going to bother, obviously, doing that by hand. We can just use a calculator for that. So we get negative 8.4, 10 minus 6 squared plus 302.4. Okay, the correct answer comes out to 168. So it's at a depth of 168 meters 10 minutes after it entered the water. All right, here's how you could do the entire problem in Desmos. First, we create a table. In that table, you only need to enter the 12,0 point. You don't need to enter the vertex point because that point is going to be, those values are going to be entered in for h and k. So again, h is 6, k is 302.4. Note, the quadratic regression for like the linear, or not for linear, for the automatic regression, like little button up here, notice it didn't show up because I only entered 1 point, but if I'd entered 2 points, the automatic regression thing would pop up. The quadratic regression by default is standard form. It does not have vertex form built into it. So this you do have to type by hand. All right, so now we get A. So now the question is, what is this equal to when x is 10? So there's two ways you could do this. You could just do f of x equals a times x minus 6 squared plus 302.4, and you could say, well, what is f of 10? It's 168. That's one way to do it. Or an alternate way is you could technically just go x equals 10, and then you're going to have to zoom out here and see where they intersect. I mean, it's kind of tricky, but eventually if you click around there, you can see it makes a clickable point. Okay, what is its depth when x is 10? It is 168. So that is just confirmation of how you could do the entire problem, again, in Desmos. Next up, question number 21. Here we have a unit conversion question. And basically we have 250 square feet per hour. And we want to convert this to square meters per minute. So first, for the hours to minutes, we can just note that 1 hour is equal to 60 minutes. And then we can worry about the square feet to square meters. So notice 3.28 feet is equal to 1 meter. However, because this is square feet, which is an area, you need to either square this factor or you have to write it twice. You do not just multiply by it once. Technically, what you're going to do is you're going to multiply by it twice. So on the top, I'm just going to go to Desmos to do this. You've got 250. On the bottom, you have 60 and you have 3.28 squared. So you multiply this all out, what do we get? 0.38729. Well, that's closest to 0.39, if you would round it. So correct answer to this one is just letter A. Next up, we have question number 22, the last problem on this practice test 9, module 2B problem set. And one thing I just want to mention is, so there's a problem with the recording where basically the audio essentially cut out. There's no audio for the last half of this problem and for the conclusion of the video after that. So I'm re-recording this problem, but I'm doing it from a PDF instead of actually in Bluebook, just because I don't want to spend the time to having to go back into Bluebook and go through module 1 again and answer all the questions correctly to get module 2B and then skip around in there. So just be aware, for this problem only, it's being done from a PDF, not inside the actual Bluebook app, but of course it's the same question, and I'm just going to solve it using the web version of Desmos rather than the actual Desmos built into Bluebook. All right, so with all that being said, this problem also is a repeat question. It's from one of the linear paper tests, 1 through 3. I don't remember exactly which one, but we have two lines that are perpendicular, and we want to know which of these other two pairs of lines will also be perpendicular as well. So the way I would approach this is I would take the top line and I would get it into slope-intercept form by moving the x term over and then dividing by 7. And that would give me this line. So I would note that the slope of the top line is negative 5/7. Then I would do the same to the bottom line. And I would get negative ax plus 1 divided by b, y equals negative a over bx plus 1 over b. Okay, so now I have the slope of the top line, I have the slope of the bottom line. Note, these are in standard form. So if you know the shortcut where the slope is just negative a over b, and you could just look at the top line and say, oh, the slope is negative 5/7, and look at the bottom one and say, oh, it's negative a over b. That's fine. If you don't want to have to do this work to get the slope, I mean that's fine. That obviously will save you time. Okay, so these lines are perpendicular. That means that the slope of one is the opposite reciprocal of the other. So if the slope of the top line is negative 5/7, then a perpendicular line will have a slope of 7/5, the opposite reciprocal. The negative becomes positive and we flip the fraction 7 to bottom, bottom to top, 5 top to bottom. Therefore, the slope of the second line, which is negative a over b, will equal positive 7/5. Okay, so now I can choose a value for a and I can choose a value for b that makes this proportion true. So I'm going to choose negative 7 for a and positive 5 for b. All right, so now the easiest way that I know to do this problem is just to go to Desmos, and of course I can't actually click the button to bring it up because I'm not in Bluebook. So instead, I'm going to bring up the web graphing, the web interface here. And I'm just going to type in each line, each answer choice, which involves 2 lines, but it's actually not going to be that bad because a lot of them are very similar and you just have to edit like one thing. Okay, so right here, just slide this up here. I'm going to set A equal to -7 and I'm going to set B equal to 5. Okay, this is answer choice A. Do these 2 lines look perpendicular? No, absolutely not. So that one's out. What about if I change this to plus? Okay, now, yes, these 2 lines do look perpendicular. These do look like right angles. So B is going to be the correct answer. But just to confirm, or just to show it to you that C and D are wrong, let's say we want to do C. So I make this 2 and I get rid of this 2. Okay, these 2 are clearly not perpendicular, so we can ignore them. And then with D, I have to edit the first one. And now we have the second one. Okay, here again, you can clearly see these 2 lines are not perpendicular based on the values of A and B that I chose. Okay, so again, the correct answer is going to be letter B for this problem. So I hope you enjoyed this video covering all 22 questions from Bluebook Digital SAT Practice Test 9 Math Section Module 2B, the harder of the two second math modules. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you have any questions or comments about alternate solution methods, feel free to leave them in the comments below. And if you haven't done so already, please do check out the videos for Practice Test 9 Module 1 and also Practice Test 9 Module 2A, the easier of the 2-second math modules. And lastly, if you are looking to learn Desmos or expand your understanding of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It's over 3.5 hours of Desmos instruction, tips, and tricks. And it includes 45 total practice problems as well.